Welcome to homework.
This question is about the vacuum cleaner parts, armature and a brush. So the armature is given the angular velocity is equal to 4 omega s to the 3/4, and then we want to find that the brush angular velocity when t equals to 4 seconds, given that the initial angular velocity is 1 radian per second for the armature. So with this, we are able to find we want to find the angular velocity of the armature first. Okay, so alpha s is the omega s dt. So we are able to write this, and then I'm going to move the like terms to one side. Okay, and then I'm going to integrate both sides. Okay. Okay, so from 0 to t, for dt, the the omega side would have to start from the initial angular velocity omega naught to some final angular velocity at time t. Okay, and since we know that omega naught is 1, so we are going to replace this with 1. Okay, so proceed with the integration. So this is 4 times omega to the quarter from 1 to omega, and this is 4t. So we have omega to the quarter power minus 1 equals to t. That means omega is equal to 1 plus t to the 4th power. Okay. So when t equals to 4 seconds, the angular velocity of the armature would be armature shaft would be 1 plus 4 to the 4, and this is 5 to the 4, and this is 625 radians per second. Okay, and since the brush is connected to the shaft by a non-slip belt. Okay, so the same relationship applies, which is omega A RA equals to omega B RB. Okay, the speed must be the same. Okay, so this means that omega B is RA divided by RB times omega A. So this omega A is the shaft. Okay, so to make it consistent, okay, the shaft is equal to the length for the brush. Okay, then we have 0.25 divided by 1 times 625, and this is 156 radians per second. Okay, so this is the final answer for omega B at t equals to 4 seconds.